The moment of inertia is defined as the product of mass of section and the square of the distance between the reference axis and the centroid of the section. Spinning figure skaters can reduce their moment of inertia by pulling in their arms, allowing them to spin faster due to conservation of angular momentum. It plays the same role in rotational motion as mass does in linear motion. A body's moment of inertia about a particular axis depends both on the mass and its distribution relative to the axis, increasing with mass and distance from the axis. For bodies constrained to rotate in a plane, only their moment of inertia about an axis perpendicular to the plane, a scalar value, matters. For bodies free to rotate in 3 dimensions, their moments can be described by a symmetric 3x3 matrix, with a set of mutually perpendicular principal axes for which this matrix is diagonal and torques around the axes act independently of each other. Inertia is the natural tendency of objects in motion to stay in motion and objects at rest to stay at rest, unless a force causes the velocity to change. It is one of the fundamental principles in classical physics, and described by Isaac Newton in his first law of motion. Inertia is the resistance of an object to changes in its linear motion, essentially a measure of its mass. Moment of inertia, on the other hand, is the resistance of an object to changes in its rotational motion, also known as its resistance to angular acceleration. In simpler terms, inertia applies to straight-line motion, while moment of inertia applies to rotational motion. In essence, inertia is the object's resistance to changing its straight-line motion, while moment of inertia is the object's resistance to changing its rotational motion. Fan, spin wheel, and rotating wheel poses moment of inertia where inertia plays significant role in balancing object. The pulley used in industries for lifting object poses inertia. In a bus, inertia is evident when a passenger feels a backward jerk when the bus suddenly starts moving, or a forward jerk when the bus suddenly stops. This happens because the passenger's body tends to resist changes in its state of motion due to inertia. The disk's moment of inertia, a measure of this resistance, is directly related to its mass and how that mass is distributed around the axis of rotation. Inertia in a shopping cart refers to its natural tendency to resist changes in its state of motion, either at rest or moving, according to Newton's first law of motion. This resistance is directly related to its mass. The more mass, the greater the inertia, meaning it requires more force to start moving or stop once in motion. The moment of inertia in a baseball bat is a measure of how difficult it is to swing the bat, and it's influenced by the bat's mass distribution. MOI, along with bat speed and contact efficiency, affects how a baseball bat performs. A higher MOI typically means a heavier bat that's harder to swing but can generate more force at impact. Conversely, a lower MOI means a lighter bat that's easier to swing but may not transfer as much force. The moment of inertia of a coin depends on the axis of rotation. About an axis passing through its center and perpendicular to its plane. A coin, being a thin disk, has a moment of inertia of 1/2 Mr. superscript 2, where m is its mass and r is its radius. This formula applies when the axis of rotation is through the center of the coin and perpendicular to its plane. The moment of inertia essentially quantifies how difficult it is to rotate the coin around that axis. Same strategy applies to merry-go-round. In the context of rotational inertia, the axis of rotation is an imaginary line around which an object is rotating. It's a fixed point or line that all other points on the object move in circular paths around. This axis can be inside or outside the object, and it's perpendicular to the plane of rotation. When an object rotates around a fixed axis, all points on that axis remain stationary while other points move in circular paths. For many rigid bodies, the axis of rotation can be thought of as passing through the center of mass. Inertia, or more specifically the moment of inertia, describes how an object's mass is distributed around an axis of rotation. It's a measure of how resistant an object is to changes in its rotational motion. The more mass an object has and the further that mass is from the axis of rotation, the higher its moment of inertia, and the harder it is to change its rotation. A solid sphere with the same mass and radius as a hollow sphere will have a lower moment of inertia. This is because the sphere's mass is distributed more evenly around the center, while the hollow sphere has most of its mass concentrated on the outer surface, further away from the axis. In essence, inertia is a way to quantify how resistant an object is to changes in its rotational motion, and this resistance is directly influenced by the object's mass distribution. The mass distribution of an object significantly impacts its moment of inertia, which is a measure of an object's resistance to rotational motion. A larger moment of inertia means it's harder to get the object rotating or stop it from rotating. The more mass is concentrated further away from the axis of rotation, the larger the moment of inertia. A higher moment of inertia means greater resistance to changes in rotational motion, making it easier to maintain and balance, while lower moment of inertia results in quicker angular acceleration and more difficult balancing. Moment of inertia plays a crucial role in balancing objects because it determines how difficult it is to start, stop, or change the rotational motion of an object, which directly impacts its stability and ability to balance. Essentially, a higher moment of inertia means greater resistance to changes in angular velocity, making it harder to topple or shift an object out of balance. In skating, the moment of inertia is crucial for controlling rotational speed during spins and jumps. A skater can change their moment of inertia by adjusting the distribution of their mass, primarily by changing the position of their arms and legs. By pulling their arms and legs in, they decrease their moment of inertia, which allows them to spin faster. Conversely, extending their arms and legs increases their moment of inertia, slowing down their spin. Radius of gyration is defined as the radial distance to a point which would have a moment of inertia the same as the Bode's actual distribution of mass, if the total mass of the body were concentrated tree. The radius of gyration is a measure of how a mass is distributed around an axis of rotation. It represents the distance from the axis where the entire mass of an object would be concentrated if the object were to have the same moment of inertia. Essentially, it's a way to visualize the inertia of an object.